This is the second part to the tutorial for the crazy 3x3x3 Neptune. In the first part, I solved this 2x2x2 chunk. And now I'm going to reduce all the edge pieces and all the corner pieces. So to do this, pick any side that moves independently, so the yellow, red, or green in my case. And you're going to use these two open slots to reduce all of the edge pieces. So the first thing you have to do is to have two unsolved pieces up here, like this, and make sure that the one outer edge piece matches with the other inner edge piece. So in this case, there's none that match. So now I'm going to have to find another one. So right here. Now looking at it, I have a red outer edge piece here and a red inner edge piece here. So when I turn this face, this is now solved. And now I want to replace this with another piece that is unsolved, like this piece, and move it back so that these three are not changed. And while doing that, I ended up solving this one as well. So now I want to replace this with another piece. For example, this one. And again, check to see if any of them match. In this case, none of them don't. None of them do. So I want to replace them again. Now I have a white outer edge piece, a white inner edge piece. So solve for that, and then replace it. And when I move it back, these three are still solved. And now I want to find another one, because none of these match again, and just repeat that process. So again, these two now solve, and move it back. Now these two will solve, replace it, and move it back. This one's also solved. And using the system of replacement, solve for all the other ones. Now I have a white and a white, match them, replace, and move it back. Reduce. Orange and orange. Now I have a red and a red. This one's now solved. Green and a green. Okay, now that I've come to this point, I only have two pieces left. This yellow, white, and this white, yellow. So now from here, I want to solve for these two. And since I usually end up using three pieces, the two pieces that are first unsolved up here, and then a replacement piece. So since I can't replace any of them that are not solved, since there's only two that are left unsolved now, first I want to match up one of them. Now I have to substitute this with another piece. And in this case, I want to substitute it with a solid yellow piece, because when I move it back, this outer edge yellow piece will match with an inner edge yellow piece, and the outer edge yellow piece that was once here will match with this yellow inner edge piece. So find a solid yellow piece, like this one. And now when I bring this one back, all of my edge pieces are now reduced. Now, I want to reduce for all the corner pieces. So, before I do anything, I want to solve for just the cross of either the red, green, yellow, or whichever side is independent. And I want to solve for the cross completely. So, I want to also match it with these centers here. Now my cross is complete. And the only corner you have to worry about not changing is still this corner right here. Now from here, I want to solve for all of these corner pieces by pairing them up. So I see an outer corner orange and an inner corner orange here. So I match that up. Now to take this out and replace it with another piece. So now I have to make sure I can only take this out using sides like white, orange, or blue, or all the sides that move with the circle, so that I don't change these edge pieces that I just solved. So I can use a white and orange piece, so I'll just replace it with another piece that's not solved like this, and move it around. And I see a blue here, and a blue here, and an orange here, and an orange here. So once I do this twice, these two are now solved. Now I can replace them. I can use blue and orange, so take it out, replace it with this piece, and also replace this piece using the white and orange faces. 1, 2, 3. And move this one back. And like this, I just want to keep solving these. So blue and blue, match it up. Now replace. That matches. Replace it. And right now there's none that match. No outer corner piece matches with any inner corner pieces. So I'm going to take it out and use a different piece. Like this one will match with this one now. That matches. These two match. That one matches. This one matches. Okay, so now I've gotten to the point where 4 of the corner pieces, at least 4 of them, are now completely solved. Once that's the case, you want to have all 4 of them that are solved on the bottom, and you only want to deal with the ones that are not solved. So this one, only one piece is not solved on this corner piece, so I'm going to rotate this so this piece is on the top. Now from here, only this corner piece has 2 pieces left unsolved. So I want to solve for this one first. There's a red on top and there's a red inner corner piece here. So from here I want to rotate it again, so now the green is on top. Like that. And now, when I solve for this, first if I look over here, if I move it over here, then these 2 pieces are now completely solved. Then these 2 are the only ones left unsolved. But since I have to move this one back before I can do anything, I have to replace these pieces. But since there's nothing that's left unsolved, I want to use either both greens or both reds. By doing so, I can minimize the amount of corner pieces that are changed to red and green. So I'll replace these with red. So I'm just going to take this out and rotate it. So now the red is on top. Same with this one. Take it out. Rotate it so the red is now on top. Now when I move it back, now only these 2 are left unsolved. Now I can move this over to here, and now the last corner piece is now solved. And from here, I want to solve for this whole side, as if I'm solving for a regular 3x3x3 cube, making sure I don't touch the yellow, green, or red sides, until I'm done with the whole face. So this piece does not come up here since the green doesn't match with any of these. This piece comes over here. This piece comes over here. Okay, so now my whole first layer is done, and everything else looks like a regular 3x3x3 cube now. And from here, I also want to make sure that I avoid using certain 3x3x3 algorithms, as most of them end up using one of these sides at least. So from here, I'm going to use the F2L method to solve for this second layer right here. So to use the F2L method correctly in this case, you want to make sure that the side that's on the bottom, so I can match it up with this side, so white's on the bottom and green's on the top. You want to make sure that the side that corresponds to any of these independent faces, you have to make sure that that color is on the top, and the one that moves with the circle, that color is on the bottom. So in this case, it's already on the bottom. And from here, I'm going to make sure I use nothing but the white face and the orange face, since they move dependently with the circle. So once it gets into a situation like this, I'll move this to the back with the white on the right. And now I'll do R, U invert it, R invert it, U invert it, R, U, R invert it, U, R, U, R invert it. And that solves for this edge piece. Now I'm just going to take this one out using the same F2L method. In this case, I don't need an algorithm. I'm just taking it out and putting the corner piece back in. Now once it's in here, again, since this one has both dependent sides, I can start with either the white on the bottom or the blue on the bottom. Since the white's on the bottom and it moves in this way, I'm going to start with that on the left. Now from here, I'm going to move this to the back again, and this time, since it's on the left and not the right, I'm going to do the exact opposite of what I did. So while this is in the back, I'm going to do L inverted, U, L, U, L inverted, U inverted, L, U inverted, L, inverted, U inverted, L. And that solves for that piece. And again, I'm going to take this out using the F2L method without necessarily an algorithm. Just put in the corner piece, making sure that this edge piece doesn't follow along with it. And right now, the yellow piece is on the bottom, but the yellow piece moves independently with the circle, so I can't have that on the bottom. So I'm going to take it to this side, and I'm going to use an algorithm that utilizes the top, right, and front faces, so that I can end up using these three sides that move with the circle, and therefore not mess up any of the reduction I've done. So I'll start here with it on the top in the front, and I'm going to use the front, right, and top faces. I'll do F, R, U, R inverted, U inverted, F inverted. And all that does is it flips this one around. Now again, this is on the left side going this way, so I'll start with the yellow face in the front, and I'm going to move this to the back. Again, I'll do L inverted, U, L, U, L inverted, U inverted, L, U inverted, L inverted, U inverted, and L. And that solves for this edge piece as well. So now my second layer is now complete. Now I'm going to solve for the top cross, again using the same algorithm I did before to flip around this edge piece that uses the front, right, and top faces. I'll do F, R, U, R inverted, U inverted, F inverted. That solves for the cross. Next thing I want to do is to solve the whole orange face. So without worrying about anything that goes around down here, I just want to make all these the same color. So from here, since I have 3 going down this way, I'll just start here. All 3 of these pieces have to go clockwise. So from here I can do R, U, R inverted, U, R, 2U, R inverted. Okay, so using that algorithm you can just play around with it and get all the orange faces on top, since there are so many situations that can arise. So once you have all the orange pieces on top, you want to look at this side and try to match the corners together. So in this case, these 2 corners match, but these 2 don't. The way to match these is to flip these 2, and then all the corner pieces will be solved relative to each other. And to do that, I'm going to use an algorithm taken from the 2x3x3 puzzle. And that takes the 2 that I'm not moving to the left, and the 2 that I'm changing to the right. And again, I'm going to use the front, right, and top faces. So the 2 I'm not changing on the left, the 2 I'm changing on the right. So 2R, U, 2R, U, inverted, 2R, 2F, U inverted, 2F, and originally the algorithm makes you do D and then 2R, but since I'll change this part, instead of that, I'm going to add an extra step. So after what I just told you, I'm going to do U inverted, 2F, 2R, 2U, and then 2F. And now all that's changed is these two. And changing this is really easy. All you have to do is 2R, 2U, 2R, 2U, 2R. And now once I've done that, my first two layers are still solved, and all the corner pieces are now solved at the top. Now from here, you can use several algorithms. You might know the one that swaps these 3 pieces counterclockwise or clockwise, or you might use other algorithms. I'll use algorithms that swaps either these 2 pieces or these 2 pieces. In this case, I just have to swap these 2 with each other and then these 2 with each other. So from here, I'll have the 2 pieces I'm swapping in the front and the right. Now I'll do 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. Now as you can see, that swaps these 2 pieces again. But now, once I do these 2 again, then this will also solve. And this puzzle always works so that no matter what you do up here, once you've finished solving this, as long as everything else is solved, these 2 will always pair up correctly. So when I swap these 2 in the front and the right, I'll do the same algorithm again. Front and the right, and 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And now it's solved. And before I end, I just want to show you one other thing. So before I said I usually use 2 algorithms, one that swaps these 2 or one that swaps these 2. I only showed you the algorithm that swaps these 2, but the one that swaps these 2 is also really easy. That's the one I showed you earlier, even earlier. So all that is 2R, 2U, 2R, 2U, 2R. And while it swaps these 2, it also swaps these 2 as well. So that's a really simple algorithm. And that's how you solve the crazy 3x3x3 Neptune. Thank you for watching.